Here's another example of a hydration reaction of an alkene. We're going to start by naming our molecule. We have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So the way that I'm going to number it is from this side, so that the branch has the smaller number on this first methyl group. Because either way I number from, the alkene has the same number, and that would be 3. So I'll go 1, 2, 3, 4, 5, 6. So this is going to be called hexene, and the double bond is at number 3. Now, we need to establish whether or not this can be a cis or trans isomer. And in this case, it cannot be a cis trans isomer because where the double bond is between carbon number 3 and 4, a carbon chain coming in, and then on the other side we have 2 carbon chains going out. And they're both different. So since there is no common carbon chain, or an H on either side of the double bond, we cannot have cis-trans isomers. So this is simply called 3-hexene, and then we name the 2 branches. We have a methyl group at carbon number 2 and carbon number 4, so we call it 2,4-dimethyl 3-hexene. 2,4-dimethyl 3-hexene, and we're going to do the hydration. In order to do hydration, we need to have an acid catalyst. And now we just need to decide where the H goes and where the OH goes. In this case, we are going to have a Markovnikov rule reaction. And this means the H is going to go on the carbon that has more H. H to C with more H. This carbon, carbon number 4, has 1, 2, 3, 4 bonds to it. Therefore, there is no H on that carbon number 4. Carbon number 3 has 1, 2, 3, so there is an H. And I'm going to draw in a light dotted line that H, just so we know that it's there in this case. So there is an H there. So that means that the H is going to go on carbon number 3. The OH is going to go on carbon number 4, as it's written right there. So that is according to Markovnikov's rule. So I'm going to redraw the carbon skeleton. We have 6 carbons, 1, 2, 3, 4, 5, 6. We have a methyl group right there. We have a methyl group right there. And our 2 carbons that will receive the addition of the water are this one right here and this one right here. This one that was carbon 3 got the H. This carbon right here will get the OH. So that is what the alcohol goes on. And so we've drawn our product. Remember, because it's a line bond structure, there are 2 H's here. There never were any H's there. Now we have the alcohol there, and we have our product. We want the alcohol to have the lowest possible number, so the numbering actually switches to the other side. So it's 1, 2, 3, 4, 5, 6. Because the alcohol takes precedence and needs to have the lowest number. So this is called 3-hexanol. And there are 2 methyl groups, so it's 3,5-dimethyl 3-hexanol. So the product of the hydration of 2,4-dimethyl 3-hexene is 3,5-dimethyl 3-hexanol.